Planar reflections will allow you to create highly realistic flat planar reflections that are real-time on the GPU of the video card. And as such, they do come at a greater cost than using cube map-based reflections, but they have no distortion like a cube map. Planar reflections are not enabled by default. They must be enabled in the project settings. In the project settings, do a search for the word clip. Then enable Support Global Clip Plane for planar reflections. The project will have to be restarted for the change to take effect. Planar reflections are very expensive to render, as they essentially re-render the entire scene a second time. They add significant overhead to a project even when there are no reflections being rendered. However, planar reflections are very high quality and fully dynamic. They even render dynamically updated actors. Again, we'll find these under Modes, Visual Effects, Planar Reflection. Let's go ahead and drag one into our scene. We can see our planar reflection actor here. Let's go ahead and pull it up off of the floor so it stops Z-fighting. And what you can see is happening is we have a flat planar surface here that is perfectly reflecting the environment. We can now make use of this actor to reflect everything onto the mirror. To do that, first let's go ahead and rotate it so it's in the correct angle. Next, we need to adjust the size of our reflection actor. Let's go ahead and tweak our scale values. We'll go ahead and set the X scale to a value of 0.03, and then our Y will be 0.05. And we can position that so that it basically covers our mirrored surface. Here we can see the result of our planar reflection actor, and we can see we have a much more accurate reflection with no distortion. If we go ahead and press the G key to enter game mode, it hides the actor, but the reflection is still being rendered on our mirrored surface. Let's walk through some of the planar reflection settings on the Details panel and discuss what kind of effect they're going to have on the quality of our reflection. So first of all, let's take a look at distance from plane fade out start and distance from plane fade out end. And these values are going to control the fade out from the center of our reflection to the edge of our object here. So if we play with this distance from end here, which is currently set to 100, you can see as I slide that value, we're adjusting the fade out there. So if it sets it to 0, it essentially has no fade out. So let's go ahead and bring that back in a little bit, and then we can play with the start value here. All right, and so that is our fade out. We can also control the quality of the reflection. By default, the screen percentage is set to a value of 50. But if we want to bring the quality up, you can tell it's a little bit pixelated looking here. We can go ahead and set this to a value of 100. And you can see we get a much higher quality reflection here because we've basically doubled the resolution that we're making use of for the render target. Now, if you look at the edge of your reflection, you may notice there is some distortion here. In fact, if I go ahead and bring up the normal distortion strength to a value of 1000, that distortion becomes a little more apparent here in the reflection. It's just a slight bending here of our reflection. There's a couple of ways we can fix that. First of all, we can drop our normal distortion strength further down, and you can see as we do that, it eliminates that distortion, but it also affects the reflection here. So if we bring that back up, you can see how it's kind of tweaking the reflection angle. So another option we have for getting rid of this distortion on the edge of our reflection is we can tweak the extra FOV or field of view setting here. And this is going to give us some extra breathing room in our render texture here so that we can get rid of that distortion. So I'm going to bring this up to a value of about 5, and what it does is it completely eliminates that distortion along the edges of our reflection. Just keep in mind, if you do tweak this setting to remove that edge distortion, you're going to increase the GPU cost. And the same thing is true when you're adjusting the screen percentage. Once we have our reflection settings all the way we like them, we're ready to go ahead and hide the planar reflection actor. We can use this show preview plane. We can uncheck that to hide it, or we can simply go into game mode because this object will not be rendered in real time. And now we have our high quality real-time reflection being projected onto our mirrored surface. Another type of reflection that we can use are post-process based reflections or screen space reflections. These reflections are rendered again on the GPU much like planar reflections, but these are done in the post-process part of the render pipeline. Like planar reflections, using screen space reflections can be expensive. and there are some drawbacks. Keep in mind, however, that planar reflections are orders of magnitude more expensive to use than screen space reflections. Screen space reflections are almost entirely based upon quality times screen resolution, whereas planar reflections have all of the same fill rate issues of screen space reflections, plus the CPU overhead of re-rendering the entire scene. In order to use screen space reflections in our scene, we're going to need to select the post-process volume in the scene. Then we'll scroll down towards the bottom under Rendering Features and find Screen Space Reflections. Right now, the intensity of my screen space reflections are set to 0, effectively turning them off. Let's go ahead and set them to a value of 100. You can see as I play with the slider here, the reflection changes in the mirror. You can also see one of the drawbacks of screen space reflections. They only operate in screen space. That is, they only operate on objects that are visible on the screen. Anything that is not currently visible in the camera's view frustum will not be rendered in the screen space reflection. For instance, let's go ahead and move our camera around here. As we pull back away from the table, you can see the chairs beginning to render on our reflection here, and they're being blended together with the cube map-based reflection. This is obviously not a desirable effect. We can also go over here to the side and get a very oblique angle on our mirror here, and you can see that as I move my camera around, we see the screen space reflection having an effect here. So we can see all of the kitchen area here, which is currently on the screen, being rendered onto the mirror. But as I move my camera so that those parts of the kitchen are no longer on the screen, those parts are no longer being rendered using screen space reflections. Obviously, for a surface like this mirror, screen space reflections are not going to work very well for us. However, in the case of our floor here, which has a glossy reflective surfaces, screen space reflections work really well. You can see as I play with the slider here, going down to 0, what our floor looks like without screen space reflections. And then we'll go ahead and bring this back up to 100, and now the floor looks much nicer. The type of reflections you use in your scene will obviously depend upon the style you're going for, but will also depend upon your hardware restrictions. For instance, if you're using a low power device, you may have to stick with using reflection capture actors versus planar reflections or screen space reflections, which run on high-end GPUs. And in some cases, you may be able to use a mix of all of the technologies. Regardless of your choice, you'll find all the options you need inside of Unreal Engine to produce high-quality reflections.